I am Anushka Srivastav. Welcome back to my channel. So this is my 11th video which is on logistic regression modeling. So let's see what do we mean by it. Logistic regression is a statistical method used for analyzing dataset where the dependent variable is categorical. It is one of the most popular technique in the field of machine learning and data analysis, especially for binary multiplication problem where the target variable has two possible outcomes such as yes, no or true and false. Types of logistic regressions are as follows. Number one, binary logistic regression. The target variable has two categories. Number two, multinomial logistic regression. The target regression has three or more unordered categories. Number three, ordinal logistic regression. The target variable has three or more ordered categories. Risk of logistic regression. It is simple and easy to implement. It is interpretable. Coefficient indicates the relationship between features and target variable. Works well when the classes are linearly separable. Disadvantages of logistic regressions are as follows. Number one, assumes a linear decision boundary. Number two, performance may degrade with high dimensional or high correlated data. Number three, sensitive to outliers. How to perform logistic regression using Python. Here is a step-by-step guidance. Number one, import libraries. Number two, load and preprocess the data. Load the dataset, inspect the dataset, split into feature 1 and target Y. Replace outcome with your target variable, split into training and testing set. Create and train the logistic regression model. Initialize is logistic regression model. Increase max iteration if the model does not converge. Train the model. Number 4. Make predictions. Predict on test sets. Predict probabilities. Probability of positive classes. Number 5. Evaluate the model. Accuracy, confusion metrics, classification reports. Number 6. Interpret coefficient. The coefficient provides insight in the relationship between features and the target. Get coefficient and feature names. Here is a complete code. Now let's discuss what do we mean by Poisson regression. Poisson regression is a type of generalized linear model used to model count data and rates. It predicts the expected number of occurrence of an event based on one or more predictors variables. The response variable in Poisson regression is a count, and the distribution of the response variable is assumed to follow a Poisson distribution. Types of Poisson regressions are as follows. Number 1. Standardized Poisson regression. Model count data where the response variable follows a Poisson distribution. Number 2. Zero inflated Poisson regression. Used when the data contains an excessive number of zeros count. Number 3. Negative binomial regression handles over-desperation in count data where the Poisson assumptions of equal mean and variance is violated. Number 4. Quasi-Poisson regression, another approach to handle over-desperation where the variance is assumed to be proportional to the mean. Number 5. Hurdle Poisson regression, similar to zip regression but models zeros and positive counts separately. Advantages of Poisson regression is number 1. Suitable for count data. Number 2. Handle non-negative integer dependent variable effectively. Number 3. Provides interpretable ratio for prediction. Of Poisson regressions are as follows. Number 1. Assume the mean and variance of the dependent variables are equal. If this is violated, the model may underperform. Number 2. Sensitive to outliers and over dispersion. How to perform Poisson regression using Python. Step by step to perform Poisson regression in Python. Number 1. Install the required libraries. If you haven't, you should install it. Install states model and pandas using pip. Number 2. Import required libraries. Import the necessary modules. Number 3, load and prepare data. For example, assume you have a dataset where you are trying to predict a count variable. Replace this with your own dataset. This is our dependent variable, this is our independent variable, and this is our independent variable too. Check the first few rows of dataset. Number 4, fit Poisson regression modelings. Use the formula API in states model to specify the model. In the formula, count feature 1 plus feature 2 indicates that you are predicting the dependent variable count using the independent variable feature 1 and feature 2. Number 5, make predictions. After fitting the model, you can predict the expected value for the data. Number 6, interpret the coefficient. The coefficient outputted by the model are in log case, log scale. To interpret them in terms of rate ratio, you can exponentiate the coefficient. Here is the complete code. I hope all your concepts are clear. I am ending my lecture over here. Thank you so much. See you in the next video.